Oops, starting to go. Ha ha ha! Yeah! Okay. Oh my God, it does work. Wow. Well, evidence-based approach, but still, I am kind of genuinely surprised that that has all come clear and all moves. And best of all, it is indeed posable because it is just stiff enough. Well, that's great. Standard open arm mini, ready to go. Printed on a bamboo A1 with a 0.4mm nozzle and a 0.2mm layer with supports for angles above 30 degrees. Download for free on GitHub. Oh, that was a crack. Might go. Yeah! Yeah! Ha ha! I gotta say, I really did not expect that to work. Oh, that's cracking. Okay, it has printed. Well, it printed successfully. Let's see what happens when we peel it. I'm going to peel it, and that's the original for size comparison. That is 42% of the original, scaled around the origin. Took 5 hours, 50 or 60 grams. These are the test pieces, the clearances. 0.1 doesn't move, 0.5, but 0.2, at least the second time, was clear. I suspect that that's because it was printed along with 0.25 at the same time. There is a difference between printing 1 and printing 2 in terms of the cooling times, and that affects how they stick together. 0.3, 0.4, which is what I'll probably do next, which is really quite loose. Also means it can be printed on an SLA, and 0.5, which is what I started with, which obviously moves. But actually, no, to be fair, when I printed that one, it wasn't obvious. I'd never tried it before. So that's the process. This is the test at 0.2. So, in theory, as I take off the supports, it should all start moving. I don't believe it. We shall find out. Always recommend wearing gloves when peeling with sharp tools, and frankly, even with your bare hands, because maybe not the PLA, but certainly with the harder materials like the carbon. That's what it looks like in carbon fibre. Well, not those aren't something else, obviously. It can cut you regardless, and being cut is a pain because it means you leave blood stains and everything. Right, from memory, all of this should just pop off fine. Oh, logo finally included on the SO. Something obviously should have done on the original. TRS, TheRobotStudio, a place for people to learn about building robots. So it's worth having a good look at the 3D model before you start peeling, because otherwise this is very easy to rip off things that should not be ripped off. I often forget myself, so I'd like eventually to produce an app which shows you all Lego style instructions or something. Not sure yet what the best way to do that is, but we're working on it. Okay. That's stronger than I thought. I think if we can get enough Should we just pull this whole lot out? I wondered maybe if the front was freed off. I guess the hope is at some point that everything just starts kind of moving freely. Oh yeah, that joint does appear to have worked. Just for risks, I'm going to break the print by forcing it. Actually, I'm going to leave that intact, so that leaves a little bit of a handle. So, as always, the devil is in the details. I'm sure there are better ways than others to peel this. Hard thing to predict at the design stage. Okay, so I'm going to clear a bit more back here. Stay in shot. How's that? Okay, so it looks like that joint is starting to move. This one is pretty firmly held together, as is this one. Very tempting to force that, but I'm pretty sure the outcome will be that I'll snap the neck off this. What else can be removed? Ah, okay. That's not going to help at all. And maybe here as well, I think, looking at it. Okay, that's a nice one.
Ooh, hello. What do we hear? That's a keeper. Yes, put it in the skin box, please.
So you can see now where that's being held in place. Okay. Wow. Ha! I really was not convinced. That's the first time I've done a joint of that length. It's completely perpendicular to the bed, so that's the worst case. So that is very encouraging. Oh. Right, what's next? Let's see if we can crack this off. And of course, the reason to go down to 0.2 and not something a bit looser is that the hope is that it would be stiff enough to stay in place once it's posed. And so far, that's not bad. I don't want to damage the print itself. It'd be lovely for that to pop up in one hit. Let's remove what we can from the front end, make it easier. Oh, that was a crack. Might go. Yeah! Yeah! I gotta say, I really did not expect that to work. Oh, that's cracking. Lovely, lovely. Ah! Well, there you go. Have faith. Wowzers. Ah! Oh, that's fun. Ah, right, okay, right. Get a grip. Don't mess it up now. Got to say, by nature, I'm a real swearer, so I will do my best to keep it in. There we go. Okay. Be nice to dig all of this out of there, I think. Don't know the ease for doing that is. Might not be stopping the joint from moving though. You can always change just, well, sharper you go, the more dangerous it becomes, obviously. So if you can do it all with screwdrivers. I think that's probably jammed up this end. Yeah, okay. See what we can get out. So the other important rule, never peel towards yourself.
I'm peeling.
Oh, that's just disgusting.
Generally never cut towards yourself, but it goes just as well for peeling. Anytime you're using a sharp tool and you start to feel yourself applying a bit of pressure, if you're going to end up stabbing yourself with it, if it slips, you should feel alarm bells ringing. Trust me on this one. If there's some little, yeah, I think there's a little recess down in here actually, so that could be tidied up from the print file. Generally the most satisfying, see if you can get a whole bunch in one go and it comes off a nice crack. Actually happens a lot more in the carbon than it does in the PLA. Because PLA itself is not particularly strong. Whereas for carbon, you end up with a very strong support attached to a very strong structure. And if you get it just right, a very weak joining layer. But PLA has improved vastly since I began printing. I used to have terrible results with PLA back before there was PLA Plus and all these variants. I say, can't detect any real difference between PLA Plus, PLO High Speed, all these other things. I suspect that's just a bit of marketing to bloat the market and give the illusion of better choice. Maybe if you get really good at it, there is. But for the casual user, PLA Plus, PLA High Speed, PLA Rapid, PLA anything. In fact, even PLA Basic has turned out to be better than some types of PLA Plus. Oddly in the colour blue. And I say oddly because it seems odd to me that any colour can affect the print quality. But my observation is very much that it does. Green is quite crispy. Orange, which I've used for the pulleys, is feels more elastic. And I don't think it's just colour influence. I think genuinely there is a difference. In fact, I know there is because the blue turned out to be considerably weaker than all the others. And print light, not very well either. So, yeah, PLA colour makes a difference. Right, that appears to be catching on something. So we should be a little careful this first time. But the other hope, because there's a flat, is that a little bit of the support material will in fact get wedged in the joints. And that this will serve as a kind of friction system, and that does appear to have worked. Either that or it's just a slightly tight fit. And because this was derived from the original CAD, it has a lot of detail. In fact, it's got all the fine detail. No doubt some folks will print this on a resin printer. This is only a 0.2 layer. Ooh, something I could have fixed in the CAD as well there. Yeah, it doesn't guess that's accurate, but it's a pain to peel. Okay, so just a couple of tweaks. But I've already published this STL file yesterday, and a few people, I think, did print it overnight. So I hope to get some results from a bunch of people today. Oh, I don't know, actually, that's quite nice once it all comes out. I like that it's accurate, but then I am an engineer, so might not be what everybody likes. It's generally been my experience, the things that I've designed, but what I think is really cool, particularly aesthetically, is not everybody's cup of tea. Okay, but the SO arm has been a really nice verification, validation that open source can fly, can really make an impact. So I'm giving serious consideration to doing a mini Hope Junior that uses microservos, because that would be a lot of fun. And the scaling thing is quite fast. It's probably taken, well, 2 sessions, so 6 hours of actual elapsed time of what I consider proper work, which generally I can manage a 3-hour stint before I notice that I'm starting to wander and I start making mistakes. So particularly if you're trying to achieve a kind of flow state, so it really wasn't with this. This is, frankly, an AI could have done this. It should have been possible to just say, take this design and shrink everything down and keep these clearances. And I can only hope that the next generation of AI tools coming out will do that. But for now, it's all manual. So I realise it's kind of like a warm day exercise for me, having done a lot of CADing recently and a lot of prototyping. It does take a physical toll as well. But all of it mental, physical. It's just I need to warm down. And I need to then consider and have a look at my technique. So we can build the next generation. Oh, that's nice. Oh, lovely. Even better. Now, of all the joints, this is the one that should definitely work, because it worked in the test one. But it's not how life works, so let's not count our chickens. Oh, there you go, it does. Oh, there you go. So, that's good. That will stay put. That will stay put. I'm sure it'll stay upright. Could do a bit of weight in the bottom. Might have to nail it to something. Right. Pitch rotation. Base rotation. Pitch. Elbow. Wrist pitch. So, last one here. 2 more. Can the gripper rotate and can the gripper open? And I'm feeling reasonably optimistic. The answer to both of those questions is going to be yes. What should I start with, I wonder? So if you remove this collar. Okay, so again, little, don't know, not sure what's better. To keep it accurate with all these annoying little details to remove. I think probably for the individual doing it, that's reasonable, because you're not mass producing these, at least I'm not. So I think fidelity matters. However, that's an awkward one. It could just be got rid of, I suspect, when no one would notice. Oh! Oh my goodness. It's just, it's so unexpected in a way. Oh, and there you go. You can just access it there. Oh, that was really good. Okay. Right. Just got a little bit here, I noticed. Not sure how much that can get out, actually, thinking about it. I can be pushing at the bottom. I think, however, there is a bunch in here you won't really be able to get at very easily. Right, might come back to that later. Inside of that is hollow, so pick at it if you feel the need. So if anything, it's a tiny bit loose. That could go tighter. And in fact, oh no, I did. There's an interference down there. It's a code interference. So this was always the joint I was worried about. And so the major structural change between the 101 and the 100, and the 100 is the original one, as it were, where we didn't have any real experience of what it was like having lots of people build them, is I included this bracket here, and I used the spare servo horn from this servo, which is only supported on one end, to make an additional bearing at the bottom of the base. And at that time, we were concerned about the accuracy of the robot. But it turns out the software could handle it. So it was a decent simplification there, because that's a bit of a pain to assemble. Gosh, that is nice, but you can see the movement there. That could probably be tighter now, thinking about it. But yeah, that could definitely be tighter. Ideally, in fact, it would be better even if that was a circle and there was an insert which was pushed into that. I mean, you could actually really make that quite tight. Top would still wobble though. Well, it is what it is. None of this is about precision. That, of course, in fact, is the whole point. But if you have more intelligent control, you can get away with a sloppier hardware. And the ultimate example of that is probably people. Or maybe leopards, or some other incredibly skillful animal. But even incredibly skillful animals don't do more complicated forms of physical exercise, like playing tennis, right? I'm sure an orangutan can hit the odd ball, but I don't see it ever winning a championship. And robots might, but that's a different story. But anyway, humans, like all mammals, are viscoelastic systems, which means they have springy bits and they have damping bits, which is exactly the same way that car suspension works. Roads and the real world are bumpy. If you don't have suspension, it is impractical to navigate it, which is why, as wonderful as the Asimo was, it was never, ever, ever, ever going to be able to enter normal domestic usage. It was simply the wrong way to do it. What you're seeing coming out now is possibly not definitely the right way to do it, but arguably has gone much further towards working complex robotic systems in everyday environments. And then it's all about high torque motors, which have very little gearing to maximize what's called transparency. And that is the relationship between what you're telling the motor to do and what the system can, I guess, feel. That's different from industrial robots, which maximize for stiffness. Talking of stiffness, we may have an interference here. This one is not moving. Let's give it a bit of... Oh! Right, don't know if it's because of that stuff wedged in there, might well be. But again, I don't want to force it because it would break and that would be a real shame. But yeah, look at that! How cute is that? Okay, right, just this last one to loosen. Okay, here we go. I guess the best thing, if we can just get rid of this, then we know it's not coarse, which would be both good and bad, unless everything starts moving. Should be, it's exactly the same as all the others, except for this bit. The jaw bone is not as thick, but that should really have minimal effect. Unless there's another interference. I don't like the look of this. That seems far too tight. That might be causing problems. Oh, starting to go. Ha 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 ha! Yeah! Okay! Oh my god! It does work! Wow! Well, evidence-based approach, but still, I am kind of genuinely surprised that that has all come clear and all moves. And best of all, it is indeed posable because it is just stiff enough. Well, that's great. Standard open arm mini, ready to go. Printed on a bamboo A1 with a 0.4mm nozzle and a 0.2mm layer with supports for angles above 30 degrees. Download for free on GitHub.